In this video, I will talk about molar heat capacity. First, let's review heat capacity. Heat capacity is the amount of energy required to increase the system temperature by 1 Kelvin or 1 degree Celsius. How do we compute heat capacity C? Very simple, C equals Q divided by delta T. What is molar heat capacity? Molar heat capacity C sub m is simply C divided by the number of moles of the substance. Therefore, heat capacity is equal to the number of moles N times the molar heat capacity. How can we compute Q given the molar heat capacity? We will also need the number of moles and the temperature change. Remember, heat capacity is equal to N times C sub m equals mass times C sub s. Therefore, C sub m is equal to mass times C sub s divided by N. And then we obtain this equation. The molar heat capacity is simply the specific heat capacity multiplied by the molar mass of the substance. We are talking about a pure substance here. Both C sub m and C sub s are intensive properties. They do not depend on the amount of the system. Let me give you one example. 1 mole of water versus 1,000 moles of water. They have exactly same molar heat capacity. And 1 gram of copper versus 1,000 grams of copper. They have exactly same specific heat capacity. C, the heat capacity of a system, however, is an extensive property. So what does this mean? Extensive properties are proportional to the amount of the system. For example, the heat capacity of 1,000 moles of water is 1,000 times of the heat capacity of 1 mole of water. 1,000 grams of copper has a value of specific heat capacity that's 1,000 times of that of 1 gram of copper. In the end, remember this equation. C equals the number of moles times the molar heat capacity equals mass times the specific heat capacity. Let's work on one example problem. The specific heat capacity of water is 1 small calorie per gram per degree Celsius, or 4.184 joules per gram per degree Celsius. Now let's compute the molar heat capacity of water and Q when the temperature of 2 moles of water changes from 15 degrees Celsius to 20 degrees Celsius. First, the molar heat capacity is equal to specific heat capacity times molar mass. So it's just 4.184 times the molar mass of water. The result is 75.38 joule per mole per degree Celsius. Now let's compute the heat. Q equals N times C sub m times delta T. We have 2 moles. We have the molar heat capacity of water here. And we have the temperature change, which is 5 degrees Celsius or 5 Kelvin. The result is 754 joules. Now I'll let you work on a practice problem. 5 moles of copper undergoes a temperature change from 320.2 Kelvin to 322.2 Kelvin after absorbing 245 joules of heat. Now let's calculate the molar heat capacity of water. Remember, delta T in Kelvin is exactly the same as delta T in degrees Celsius. So if delta T is equal to 2.0 Kelvin in this case, delta T is also equal to 2.0 in degree Celsius? The answer is in font size 2.